So you'll notice that the collective motion is a wave. The balls are sampling points on the wave. The wave has a constantly changing wavelength. So it goes from wave-like behavior to what appears to be lines, to fewer lines, to ultimately kind of a double helix. Almost the DNA molecule will show up in a bit. There it is. And now the two lines show up, and the sort of the repeat pattern is halfway gone, so it starts to come back. The wave travels the other way around until it comes back home to the release point. I talk about this apparatus in a couple different ways. One is mathematically, another is physically. When people play the piano, they strike stringed instruments or strings that vibrate in a certain period, and therefore the period determines the frequency. We hear music and we think, oh, that's nice. We hear chords and we think, oh, that's very nice. The reason chords are nice to us is that the frequencies are at these certain pleasant ratios. The pendulum snake apparatus essentially has frequencies at ratios that are pleasing not to our ears, because that's not music, it's pleasing to our eyes instead. So one way to talk about this is we're seeing the music instead of hearing the music. We're seeing the chords because the ratios of frequencies are chosen to be special ratios, special numbers.
Is that it?
That's about all. I mean, we're halfway through the second cycle, and it'll just keep going until we stop it. Okay. Each time it goes through a cycle, it essentially loses a good fraction of its energy because these balls are smashing into air molecules as they go over and back, and that takes out energy. That bleeds out energy out of the system, so eventually they'll stop. Out in a vacuum, they just keep going. However, you can, if you listen carefully, you can hear some clicking. The strings hit the edge of the bolts. That's energy as well. So that bleeds energy out of the system. So even in a vacuum, we're gonna lose some energy. Yeah, pendulum wave apparatus. Physics major built this to demonstrate collective motion and explore the mathematics and physics of the pendulum. First year physics applied to a demonstration apparatus for interesting results. Wouldn't you say?
Absolutely.
All right.
Is that it?
That's the end.
Wow.
So cool. I think we just made something amazing.
Yeah.
I think we just made something absolutely amazing.